Algebra 2, we're going to take a look at the first part of 1.7. Today, just focusing on our absolute value equations, and we'll save those inequalities for tomorrow. It is important for us to recall that absolute value really truly just represents distance from 0 on a number line. So oftentimes that means there are two solutions to these equations, and we have to remember to split this up so we can find those two. However, Algebra 2, nothing is absolute anymore. We could only have one solution or sometimes even none. So you do want to make sure you're checking your work for those extraneous solutions that will pop up. Okay, now why are there two solutions when we're talking absolute value? Well, let's just take a look at something simple like the absolute value of x is equal to 5. If we're talking that is distance from 0, we're looking for all x values that are 5 units away from 0. So very simply, like first time you talked about absolute value, you count 5 in each direction. So 1, 2, 3, 4, 5, and we have a solution there. And the opposite direction, 1, 2, 3, 4, 5, and we have a solution there. So this equation has solutions of positive or negative 5. Now it is important to note that not all absolute value equations will have the solution of plus and minus the same digit. That's actually not very common, so don't get into the habit of just solving and then smacking a plus or minus in front of it. We have some steps that I need you to follow, and they are these 4. So the very first thing, isolate. This means get the absolute value expression all by itself. Anything that's added or subtracted or multiplied or divided on the outside of absolute value needs to be dealt with. Only get absolute value on by itself. The second thing you do is separate that isolated expression into two different ones, and this is where the absolute value bars will go away. One is equal to the positive quantity and the other equal to the negative. Then you solve each of those two little equations, and then lastly check your answers because extraneous solutions are possible when we talk about absolute value equations. So let's see how these 4 steps play out in these 2 examples right here. So isolate. First thing we look for, nothing is going on outside of this absolute value. There's nothing multiplied, added, subtracted, divided, any of those things. So step number 1 is done for us. Then we're going to separate. So we will have 3x, sorry about that, 3x plus 8 equals 20, or that 3x plus 8 could equal a negative 20. Okay, 20 units, this is really representing 20 units to the right and 20 units to the left with that negative. And now individually solve. So the first one, we're going to subtract 8 from both sides and get 3x equals 12, and divide, get x equals 4. That word or just keeps traveling along, and second half we have 3x equals negative 28, and x equals negative 28 over 3, because that doesn't divide evenly. I would definitely recommend that you just leave your answers as improper, fully reduced, but improper fractions. It will make it easier to do this last step. So here we're going to check. So we do absolute value of 3 times 4 plus 8, and we simplify absolute value of 12 plus 8. Absolute value of 20 is equal to 20, so x equals 4 checks out. The other one, 3 times negative 28 thirds plus 8, absolute value. So that's negative 28 plus 8, because those 3's cancel. Absolute value of negative 20 is equal to 20, so that one checks out too. Now that both have checked, I can go back, and box in my answers so we know where they are. All right, not too terrible? I hope not. Let's look at one more on this page. So we have Absolute value of the quantity negative 5x minus 3 is equal to 8. Again, isolated, there's nothing on the outside of that absolute value. So we're just going to start by separating right away. So negative 5x minus 3 is equal to 8, or negative 5x minus 3 equals negative 8. And let's solve. So negative 5x equals 11. Again, doesn't divide evenly, so we're going to leave it as an improper but fully reduced fraction. Over here, I get negative 5, x equals 1. And we want to check that real quick. Some of you might be able to check easily in your head. Writing it down is never a bad idea. So either way. But if you box in an extraneous solution, I'm going to know that you didn't check your work. So here we plug in our negative 11 fifths, negative 5 cancel. So we have, negative 5 and 5. So we have absolute value of 11 minus 3. Absolute value of 8 is equal to 8, so it checks. And over here, we would have negative 5 times 1 minus 3. So that's negative 5 minus 3. Absolute value of negative 8 is 8, so that one checks as well. Then both of them checked out, so I'm going to go ahead and box in both answers. All right? So those are pretty fun, yeah? Let's look at one that's a little bit tougher. So notice I reminded us of our 4 steps up there where we want to isolate, separate, solve, and check. And this one is a little bit harder. We see there's a 3 outside, and 3 in front of absolute values with no plus or minus sign just means multiply. So we have to isolate by dividing both sides by 3. So that's going to look like the absolute value of 2x plus 12 is equal to 4x. Now step 1 is done. We have absolute value all by itself. So we're going to go ahead and separate this out. We would have 2x plus 12 equals 4x, and or 2x plus 12 equals negative 4x. Okay, solve each one. Now x's are on both sides of the equation, so I think I'm going to subtract this 2x to both sides. So 12 is equal to 2x, x equals 6. 12, subtract the 2x over, negative 6x. Negative 2 is equal to x. Right? So, as we've been talking about, pretty important to just check our work pretty quick. So we want to go back to the original equation and check them in there. Always plug into the original to check. So 3 times 2 times 6 plus 12. So we'd have 3 times the absolute value of 12 plus 12. So 3 times 24 should be 72. And then 12 times 6, also 72. So those two check out. So x equals 6 works. Let's find out about this x equals negative 2. So 3 times the absolute value of 2 times negative 2 plus 12. Does that equal 12 times negative 2? So 3, negative 4 plus 12, which is 3 times the absolute value of 8. So that side's 24. This side's negative 24. Those are not equal. So in this case, by checking our answers, we have revealed that x equals 6 is the only one that works. X equals negative 2 is extraneous, so you can either just not box it in, or maybe put a little x through it so we know that you've checked it and it doesn't work. There's no need to write that it's extraneous, just indicate that you know it doesn't work. So a little cross through on that would indicate such things. All right? How do you feel? Let me know if you have any questions. Have a good day.